Okay, last class we are discussed how many questions, dear students? 10 questions are over. Let's see the next question. 10th question is nothing but aldol reaction application. Aldol condensation reaction application. Let's see how to write that product very easily. I will explain you mechanism and I will explain the shortcut also. Let's see. Cyclohexanone. Okay. Is reacting with another cyclohexanone, and here base OH minus on heating means it is aldol reaction, aldol condensation. Okay students, aldol condensation reaction. Now in the presence of base means what it will do, dear student? The base removes a proton. Alpha hydrogen atoms. How many alpha hydrogen atoms are present? 2 alpha hydrogen atoms are present. This alpha hydrogen will be removed by base and generates negative charge. It will be attacked and this alpha hydrogen will comes to this carbonyl group. Okay, now the product is this. And here at C double bond O group and OH, beta hydroxyaldehyde will forms. Okay, upon heating, loss of water molecule, then we are producing alpha and beta, alpha beta unsaturated carbonyl compounds will get. So the product is double bond like this. So the option is, third option is correct. Directly you want means cyclohexanone 2 moles in aldol condensation, 2 moles of aldehydes or ketones, alpha hydrogens containing 2 moles of aldehydes or ketones reacts in the presence of base. Upon heating we are getting alpha beta unsaturated carbonyl compound. This water molecule it will lose. 2 alpha hydrogens and a carbonyl group containing oxygen, loss of water molecule. Then we are getting alpha beta unsaturated carbonyl compounds. Okay, so this is the product. This is the aldol reaction. Next, the 11th one is by Cannizzaro reaction, A changes to B plus C, which is the reactant they are asked. So the Cannizzaro reaction condition, what dear students? Alpha hydrogens, without alpha hydrogens containing aldehydes involving in Cannizzaro reaction, 2 moles of alpha hydrogen, absence of alpha hydrogens containing 2 moles of aldehydes undergo self oxidation and self reduction to produce acids and alcohol. Let's see the first option, CHO and COOH, no alpha hydrogens, no alpha hydrogen atoms. So is treated with base, is treated with sodium hydroxide, then it involves in 2 moles. Whenever a base is, this acidic group is converted into salts. Then one molecule CH2OH, one molecule of CHO group is converted into, undergoes reduction to gives alcohol, another COONA. Okay, and another molecule is upon reduction, CHO group undergoes reduction to produce sodium salts of carboxylic acid and COONA. So the answer is, this is C and this is B. B and C. So the correct option is first option. This first option undergoes Cannizzaro reaction, produce sodium salts of alcohol and another dicarboxylic acid, oxalic acid. Sodium salts of oxalate, oxalic acid is forming. Let's see the second one. Just you do Cannizzaro reaction here. 2 CHO groups present in one molecule only. That is called intramolecular Cannizzaro reaction. In the presence of base, the product is COONA and CH2OH will forms. It forms only one product, not B and C. That's why it is not our answer. And this is also CH2OH is present. This CHO group is on oxidized to give COONA and reduced to give CH2OH. Another one is CHO bond CH2OH undergoes Cannizzaro reaction. The products are COONA bond CH2OH. Alcohol group cannot oxidize. And another thing is CH2OH bond CH2OH will forms. Okay, these are not B and C. So the correct reagent is CHO bond COOH upon Cannizzaro reaction produce B and C. So the correct answer is first option. It is Cannizzaro reaction application. Okay, students. Next, 12th question. Let's see. Is very very important. The 12th question. 2 times cross aldol condensation we are doing. Okay, the 12th question is cross aldol condensation reaction. Cross aldol condensation reaction. Okay, students. Now, what is cross aldol condensation reaction, dear students? Different aldehydes or different ketones are present. Then undergoes aldol condensation is known as cross aldol condensation. One aromatic aldehyde, benzaldehyde, another alpha hydrogens containing aldehyde or ketone is present. Then majorly one product will forms as major. Then it is also called as a cross aldol product. So here benzaldehyde they gave. Benzaldehyde. Okay, students, CHO is reacts with acetone, CH3, C double bond O, CH3, acetone. This is 2 moles. It is 1 mole. What is the major product they are asked? Okay, cross aldol condensation, how many times it is going on? 2 times it is going on. Because here 2, here it is also alpha carbon and it is also alpha carbon. And contains alpha hydrogens. How many alpha hydrogens are present? 3 hydrogens. Here also 3 hydrogens are present. At least 1 alpha hydrogen is required. Then only they involved in aldol condensation. Now let's see the first one. 1 mole. Benzene ring is also where considered as pH group. PHCHO. Our convenience, acetone I am writing CH2, CH bond, C double bond O, CH, CH2 I am writing here another mole. In the presence of base on heating, loss of 2 moles of water molecule. See here this alpha hydrogens, 2 alpha hydrogens and carbonyl carbon oxygen. Loss of water molecule. And here this, what is the product, dear students? Here double bond will forms. pH bond CH double bond CH bond C double bond O bond CH double bond CH pH. Otherwise bond line structures do you want to write means pH double bond O pH. This is, so the answer is pH double bond C double bond O pH means third option is correct answer. Okay, students, this reaction is very very important for board examination. Also benzaldehyde react, 1 mole of benzaldehyde react with 1 mole of acetone, undergoes cross aldol condensation. It is 1 mole only means the major product is, it is 1 mole. The major product is this CH double bond CH C double bond O, CH3 will form. Another, this already it has alpha hydrogens. Okay, so it reacts with another mole of CHO to produce this product. Okay, important this question. Let's see the next question. 13th question, dear students. In the Cannizzaro reaction given below. So in the Cannizzaro reaction given below, the slowest step we need to find out. Okay, let's see that the question Cannizzaro reaction mechanism. Cannizzaro reaction mechanism. Either whatever it may be, that Cannizzaro reaction mechanism, you can write benzaldehyde or you can write formaldehyde also, no problem. Okay, so this, for example, in Cannizzaro reaction, 2 moles of benzaldehyde it involves. The first mole, 1 mole of benzaldehyde react in the presence of base. Okay, this is the step 1. Step 1 is nucleophilic substitution reaction. The step 1 is addition of hydroxyl ion to carbonyl compound. Okay, addition of OH hydroxyl ion to carbonyl carbon. Carbonyl carbon, then alkoxide ion will form. CH, OH, O minus. Okay, so the product is hydroxy alkoxide. Hydroxy alkoxide. This is 1 mole of benzaldehyde first. Now this hydroxy alkoxide, step 2 is transfer of hydride ion. Transfer of hydride ion to another mole of benzaldehyde. Another mole of benzaldehyde. It is a slow step. It is a slow step. Hence it is a, therefore it is rate determining step. Rate determining step, RDS, rate determining step. Let's see that. O minus, this hydrogen and OH reacts with another mole of benzaldehyde. This hydride ion will be transferred. This shifting, thus O minus electron density is migrating towards carbon. This becomes more electronegative. This hydride ion will be shifting at carbonyl carbon. Another mole of benzaldehyde and produce carboxylate ion, carboxylic acid, OH plus CO minus CH2 pH or C6H5. Okay, now this proton is shifting. The step 3, shifting of proton. Shifting of H plus ion. This H plus ion will be shifting from carboxylic acid to phenyl benzyl oxide ion. Then produce O minus, and if Na plus is present, sodium hydroxide, then Na plus sodium salts of carboxylic acid will form, and another one is alcohol, benzyl alcohol. Benzyl alcohol will form. So this is the Cannizzaro reaction mechanism, dear students. In this Cannizzaro reaction mechanism, in this place, benzene place, you can write hydrogen also. Then it is called formaldehyde. No alpha hydrogens. Okay. If hydrogen, if you are kept Then what are the products, dear students? The if you are kept a hydrogen atom means sodium formate plus methyl alcohol will form. CH3OH plus HC double bond ONA means formaldehyde formaldehyde or benzaldehyde. There is no alpha hydrogen atoms. They involved in Cannizzaro reaction. In the Cannizzaro reaction, the first step is addition of hydroxide ion to carbonyl carbon, and the second step is transformation of hydride ion to another carbonyl group. Okay, so the transfer of hydride ion is a slow step, hence it is rate determining step. And the final step, the third step is shifting of proton H plus ion from to alkoxide ion and converted into sodium salts of carboxylic acids plus alcohols. So formation of alcohols is oxidation and formation of alcohols is reduction and formation of alcohol acids, carboxylic acids is a oxidation. So in Cannizzaro reaction, both oxidation and reduction both are present. That's why it is called this reaction is called redox reaction. Cannizzaro reaction is example for redox reaction. Okay, students. Let's see for next question. 14th question. It's very easy. C3H8O. Okay. C3H8O. It is one compound. This is on oxidation and produce C3H6O. H6O is treated with iodine in the presence of base, means it gives CHI3. CHI3, among that three carbon atoms, one carbon is converted into CHI3, another carbon, two carbons are converted into CH3, C double bond O. Either base means you have to use sodium hydroxide, then sodium salts of carboxylic acid will get. Is nothing but haloform test. Haloform test. So this haloform test means this compound must should be methyl ketone. Methyl ketone means three carbons containing ketone is acetone. CH3, C double bond O, CH3, acetone. This acetone is formed by the oxidation of alcohols. What type of alcohol, dear students? Here C double bond O group is formed, means it is a secondary alcohol. So three carbons containing secondary alcohol is isopropyl alcohol. HOH bond CH3. So the answer is second option. Now the resultant starting material is isopropyl alcohol or propane 2-ol on oxidation producing acetone. Acetone is treated with iodine in the presence of base producing iodoform test. Okay, so these conversions are very, very important. Now 15th question. Let's see that here meta position chlorine is present and first position CH2OH, benzyl alcohol. Now it is PCC. PCC means what, dear student? It is a mild oxidizing agent. Mild oxidizing agent, it oxidizes primary alcohols into aldehydes. Primary alcohols into aldehydes. So PCC you can use, or PDC, pyridinium chlorochromate you can use, or MnO2, manganese dioxide also it is correct. So these all are mild oxidizing agents. This oxidizes primary alcohols into aldehydes. It does not affect chlorine group. So the answer is CHO. That CH2OH converted into CHO at chlorine. Metachlorobenzaldehyde is the product. Okay. Let's see that. So answer is third option. Third option is correct. Okay, students. So your answer is third option. First option, metachlorobenzaldehyde. Metachlorobenzaldehyde is the correct answer. Okay, so the 15th answer is first one. Now let's see that 16th question. A compound A has the molecular formula C2Cl3OH. This is A, right? Okay, students. This reduces Fehling's reagent. Reduces Fehling solution. Fehling solution means what it is? A has CHO group. Okay, means it contains aldehyde functional group is present. And also one more hint they gave. And the oxidation failing solution on oxidation produce carboxylic acids. It is on oxidation. It is on oxidation forming COOH. Means how can we say, dear students, this is on oxidation means the A has aldehyde functional group, because so based on this reaction also A has a aldehyde functional group we can say, and A is formed by the oxidation of ethanol CH3CH2OH. Ethanol on oxidation with chlorine. First one mole is forming CH3, C double bond OH acetaldehyde is again oxidation with chlorine in the presence of 3 moles. Loss of 3 HCl is converted into CCl3, C double bond OH is nothing but A. What is this name? Chloral. Chloral. Okay, so the answer is chloral. So the A is chloral. Is molecular formula CCl3 C double bond OH. Due to the presence of aldehyde groups, it can be gives a positive test with Fehling's reagent, as well as aldehydes on oxidation converted into acids. Okay, so the answer is chloral. Chloral molecular formula is CCl3 C double bond OH. That's why its molecular formula is C2Cl3OH. Okay, students. Now let's see the 17th question. It's very easy and important also. What type of reaction is going on? Just we need observation is very, very important. 17th question is cyclopentanone. Okay, student. This cyclopentanone is reacts with HCN. HCN is addition of hydrogen cyanide, nucleophilic addition reaction. H plus and Cn minus. The Cn minus will be first added at carbon and carbon. This O minus and H plus converted into cyanohydrin. Okay, this is converted into cyanohydrin. OH and Cn group is formed. This is on hydrolysis in concentrated H2SO4 in acidic medium, followed by hydrolysis upon heating. Means the Cn group is converted into acid COOH, and this proton, this OH molecule is present. OH group abstract the proton H plus ions. This is abstract H plus ion is converted into H3O plus and loss of water molecule. To reduce this positive charge, this hydrogen atom will comes out. Then the major product is C double bond OH, and here double bond will forms. Alpha beta unsaturated cyclic carboxylic acid is the product. So the answer is first option. First option is correct. Okay, students. First nucleophilic addition is taking place, and hydrolysis in acidic medium upon heating. So due to that heating, the OH group is converted into double bond and Cn group is converted into carboxylic acid. Cn group is converted into carboxylic acid. That is very, very important. Okay. Let's see 18th question. Eighteenth question. See, dear students, on vigorous oxidation with potassium permanganate, what is the product they are asked? See the 18th one. C. here double bond is present, then here CH bond CH2, CH2, CHO. Okay, this what we are doing. We are doing oxidation vigorously. We are doing oxidation with KMnO4. KMnO4 is strong oxidizing agent. Strong oxidizing agent. It oxidizes this double bond into corresponding acids as well as carbonyl compounds, disubstituted. Then it is converted into ketone, CH3, C double bond O, CH3 plus this is converted into HC double bond O. This is also converted into acid. This side, this is because mono substituted, disubstituted into ketone. Mono substituent into acids, it will be oxidized into carboxylic acid. Okay, then CH2, C double bond OH. This aldehyde functional group is also oxidized to acid. So the answer is acetone and malonic acid. CH3C double bond O and CH2COO H twice. So the answer is fourth option. Okay, students. This is acetone. And this is Ohm's gap, OM, malonic acid. Malonic acid. Okay. Or methane dioic acid. Methane dioic acid. 1,1 dioic acid. Okay. Or dicarboxylic acid. Okay, let's see that. 19th question. 19th. Pfaff rule. According to Pfaff rule, heptanone, 4 heptanone means 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7. So the double bond O is a carbonyl group is present at 4th carbon. 1, 2, 3, 4, 5, 6, 7. This we are doing oxidation. KMnO4 in acidic medium is a strong oxidizing agent. It oxidizes ketones into mixture of acids, mixture of carboxylic acids, mixture of carboxylic acids. Okay, students, let's see now. This according what is the Pfaff rule? C double bond O group. This C double bond O group attached carbon. This C double bond O group attached carbon, if you are considered, that should be with more carbons containing carboxylic acid, it will forms, and means here it will be oxidation will take place. However, the C double bond O group is on middle. Right side 3 carbon atoms are present. 1, 2, 3. 3 carbons are present, and left side also 3 carbons are present. So however, it can be oxidized either right side or left side, and produced acids are what are the acids, dear students? CH3, CH2, CH2, C double bond OH means 1, 2, 3, 4, and another 3 carbons containing acid. 3 carbons containing acid means CH3, CH2, C double bond OH. means butanoic acid and propanoic acid. Butanoic acid and propanoic acid is the answer. Okay, that is called fava fruit. Now the 20th question, which are the following alkenes on reductive ozonol gives mixture of ketones. Mixture of ketones means different ketones we need to produce. Let's see that 20th first option. Here CH double bond CH bond CH3 bond CH3. Okay, is a disubstituted alkene. The ozonolysis is taking place, reductive ozonolysis. Zinc followed by hydrolysis, then produce. It is a symmetrical. That's why forms 2 moles of acetaldehyde. CH3C double bond OH. Acetaldehyde is formed. Let's see the second one. CH bond CH3 and here 2 methyls. It is trisubstituted. It is disubstituted. It is a trisubstituted. Then the double bond will be oxidized ozonolysis followed by reductive hydrolysis. Then the two substances present at one sp2 carbon is converted into ketone CH3 C double bond O CH3 and another one is becomes to aldehyde CH3 C double bond OH. Okay, now one is acetone, one a ketone, one aldehyde is formed. So we want a mixture of ketones. So the third one is double bond, here one methyl and ethyl, and this side two methyl groups are present. It is a tetrasubstituted alkene. Tetrasubstituted unsymmetrical alkene converted into mixture of ketones. Okay, students, is very important. So all different types of ozonol reductive ozonolysis reactions we are discussing. Now zinc followed by H2O. Now this bond will be break, is converted into CH3, C double bond O, CH3 acetone plus CH3, C double bond O, bond CH2, bond CH3. Okay, acetone means here 3 carbons are present, here 4 carbons are present. Butane 2-1 and propane 2-1. So the answer is third option is correct, forms different mixture of ketones. And fourth one is symmetrical trisubstituted alkene. Symmetrical tetrasubstituted alkene. Tetrasubstituted alkene converted into 2 moles of symmetrical ketones. 2 moles of a symmetrical ketone. So in the same conditions you have to apply. Then we are producing CH3, C double bond O, CH3. 2 moles of acetone is the product. So the answer is fourth option is not. Fourth option is producing ketones but not unsymmetrical. So the answer is third one. So the answer is a third one. Which compound shows Cannizzaro reaction? Cannizzaro reaction need to show means no alpha hydrogens. No alpha hydrogen means absence of alpha hydrogens are required. See here alpha hydrogens are present. So it cannot shows Cannizzaro reaction. And it is also alpha hydrogens are present. One alpha hydrogen is present. Here no alpha hydrogen. No alpha hydrogen. And here also no alpha hydrogen. So the answer is C and D options. Where it is present C and D? Second option means trimethyl acetaldehyde and benzaldehyde shows Cannizzaro reaction because they doesn't contain alpha hydrogen atoms. Okay, let's go for next question, dear students. The next one is ozonolysis, reductive ozonolysis we are doing means followed by aldol reaction. Aldol reaction. Okay. So the first product